was a very nice introduction, and I have to remember the matter to things that matter. That was cool. Thanks very much. I have to start with a disclaimer of my own. I have days where I have headaches, and this is one of them. And so my brain has gone down from its usual like 2 things it can hold at one time to about half of a thing it can hold at one time. So I am going to I'm going to try to manage, but I'm not functioning at full capacity. That's just a sad reality today. Okay, so we have about half an hour or a bit more to talk, and then we'll have time for questions. Can you hear me now? That was better, right? This is better. And I hope the Zoom people can hear me as long as I see the green microphone. That's great. Okay, so off we go. I realize, so matter is one thing. I mainly study energy because when you're a physicist, I mean, that's the main reason people become physicists, is because if you remember that energy is conserved and you walk into an exam room, your chances are okay. That's sort of the only thing you need to remember. So I sort of went from studying physics as a thing to studying social systems through energy. And so I'll tell you, and I realize you people are water people. So that's very different. So I just want to start with some basic facts about energy and well-being, and we'll take it from there. So these are stylized facts. And the other fun thing is, because I'm sort of in economics right now, I stole this stylized facts. There's a very famous macroeconomist who had stylized facts that it turned out were not facts so much as wrong. And the reason he made them stylized facts was because he didn't like the way that data contradicted his theories. But in this case, I have to say these stylized facts actually do represent my actual understanding of reality based on actual data. Okay, the first one, and it doesn't matter what the axes on this plot are, as long as on the vertical axis you have some indicator of well-being. In this case, it's the Human Development Index, which is a composite, very common indicator of well-being. And on this, the horizontal axis, you have some form of energy per capita. In this case, it's annual electricity use per capita. It could be anything. And the shape of this curve is always the same. It's what it shows is that at low levels of energy per capita, you basically have a very steep slope that is so steep that you almost don't see it. It's almost like along this line here. But what it means is that at that level, every little increment of energy use per capita is going to buy you a lot of well-being, a lot of human development, right? A little gets you a long way. Whereas out here, you basically have this high plateau. All the black countries are sort of OECD countries, and they basically just flatline. And so the point is that, between the US and Spain, there's very little difference in terms of well-being, human development, life expectancy, whatever. In fact, some of the countries out here, typically, some of them usually have a higher life expectancy than the US because the US is horrible. But you basically have like almost an order of magnitude difference in energy use and very little to show for it. So that's sort of the first stylized fact on energy and well-being, is that at low levels a little matters, and at high levels it doesn't matter at all anymore. There's this high plateau. The second fact on, and this is where I go back. Okay, what Pasternak, the reason I always use this plot is because it's actually the plot that I saw not in 2000 when it was published, but fairly shortly afterwards when I was still doing my PhD, and it's the one that launched my whole career now. It's zoomed me out of physics and into where I am now. What Pasternak was doing when he did this study is he was trying to understand what is the level of energy, the minimum level of energy necessary for high human development. And that's why he drew this bar here. He was like, gosh darn it, at 4,000 kilowatt hours per person, that's where people start being okay. That's what we need to do for everybody. We need nonsense nuclear everywhere. I've just summarized his report for you. And that's not true, because one of the things that this curve does is it doesn't stay in one place over time. This is not a development curve, is what that means. What that means is that countries do not move along this curve. They do their own things, and generally they're basically going pretty much straight up with a little wiggles. So the point is that from this curve not being a development curve is that the stylized fact number 2 is that energy decline, the energy necessary for any given level of human development goes down over time. So we have a huge, so the energy threshold associated with any level of well-being decreases over time. And this is one example of it. This is a paper I published in 2010 that shows the energy required for human development, high human development over time. And you can see that in 1975, it was like 110 gigajoules per capita. And, you know, by the time our data set ended around 2005, it was around 50 gigajoules per capita. This is a huge drop. This is major. And it means that our current present time is very different from our past time. When I was born, we had a supply constraint problem. There was not enough to go around for everybody to have high human development. Now we're in a distribution problem. There's more than enough, but it's very, very unevenly distributed. Okay, and the third stylized fact is multidimensional diversity. So if we go back to this plot now, you see the axes have changed and it still looks totally the same. You have life expectancy in years here, and you have carbon emissions, which is basically just fossil fuel use in tons per capita on the horizontal axis. And one of the things that people said is, you know, you say that we should try to be up in this little corner here at low energy use and high well-being, but only tropical islands are there. That was basically one of the arguments. And so we wrote this whole paper, which has other interesting stuff in it, to say, actually, no, there's a lot of diversity in the countries that are represented in this space of moderate resource use and high human well-being. The only countries that are not represented are the super wealthy ones. So this yellow cluster, which is the core wealthy economy, they are not represented in there. But basically, a lot of other country types are, from every single continent, from every single socioeconomic setting, etc. Okay, now if we want to go, those were some stylized facts. Who are now energy experts on energy and well-being. So if you want to go beyond, like, you know, shove energy in, measure well-being out, you have to go beyond that. You sort of have to open that black box. And we need a new kind of framework, and this is a framework we developed for this project called Living Well Within Limits that I've been doing. It started in 2017, and so a lot of the results that I'll be showing you come from this Lily project. And this is the framework, and it's pretty simple, but it actually took us a reasonable amount of time to come up with it, and I think it actually works, and I'd actually be really interested to see how, so people are starting to apply it to other frameworks like material use. I don't think anybody's ever done anything on water with it, so that would be kind of interesting. But here's the basic idea, is that you have your sort of biophysical system where you have planetary processes, and the planetary processes, the way we mess with them is we take in natural resources. So this is a view of the world where you start messing with the environment at the point of extraction, not at the point of emission, right? So I guess we're all grown-ups in this room, we all realize that our impact on the environment starts at extraction. It's when we take resources from the environment that we have a commitment to messing with it. Okay, so we're messing with it by our natural resource use, and our natural resource use then presumably does something on the other side over here, which is that it gives us some social outcomes. And the social outcomes are sort of split into two. There's need satisfiers, and which there's not a huge number of those. They're pretty there's a finite number, and we can all sort of recognize them as things that we would need. And once those needs are satisfied, we get well-being, which translates to physical, mental health, autonomy of agency, understanding, social participation, etc. The interesting thing is what's in the middle, because where I come from, either from physics or from economics, the way you put something in the middle is you say it's the economy, it's the market, or you say it's technology, or both, if you're really sophisticated. And what we wanted to do is we wanted to treat physical and social systems in a unified way. And there's not a million frameworks that allow you to do that. In fact, the only one that we were able to find really is a framework within heterodox economics called systems of provision or provisioning systems. So we basically describe this object in the middle called provisioning systems. It has both physical and social attributes, including things like culture, including things like distribution, including things like technology, supply chains, etc. So we're able to study those together, and that becomes very important. And maybe we'll get to that, to why that's important. Okay, now you might have noticed that I said I had a background in physics, and here we're doing research on well-being. And you might have put two and two together and realize that a physicist talking about well-being is not qualified. This is not something we learn about or something we practice. So that was the first issue in this research area, is we had to go and read about well-being and how to study it and how to think about it and all of that. And it's a very undignified thing to do when you're doing this, because you're picking, as an academic, you're always picking fights with people, right? And in this case, the people have been dead for a couple of thousand years. So let's see what happens. Okay, so welcome to ancient Greece. This is sort of where you have the first sort of written records of what people think about well-being that we can still sort of recognize and identify with. And this is caricatural. And every time I show this in the philosophy department, I always make sure that there's a back exit, you know? Okay, but you're Waters Reed scientists, so it's going to be fine. All right, so let's start with Aristotle. Aristotle, highly problematic. He wrote this stuff in the Ethics. Very clear, very beautiful book. This definition of well-being is sandwiched between his justification of slavery and women staying in the kitchen, okay? So like, don't watch it, okay, with Aristotle. Okay, but his idea of well-being is that well-being means being able to live life as fully as possible and flourish within one's society. So it's basically an idea of human capacity. It's flourishing, so the point is your society gives you the conditions to live well within it, okay? And just a few decades later, Epicure comes on the scene, and Epicure is going to be highly character. These are all characters. This is a cartoon version, right? We all understand. They basically have speech bubbles. Epicure, very caricatural. But his idea was that it was much more sort of individual and emotional perspective on well-being. And his idea was, okay, we want to achieve the most positive feelings and the least negative feelings possible. That's what we want to do. Okay. And so they basically had started this academic disagreement, which, if you're really good at your career, you also will be able to start an academic disagreement that lasts over 1,000, 2,000 years, right? Like, that's the way you get your citation numbers up. And so you have to choose which team you're on. Okay, if you're in Team Epicure, and this is where I start heading for the exit if I'm in the philosophy department. Your vision of well-being is it's sort of this emotional well-being, so it's sort of happiness. It's very individual. You measure it with a single dimensional indicator, like the happiness indicator, which is a genuine thing. You can go around and ask people how happy they are, and you average it, and then you publish it, okay? Or the utility function in mainstream economics, where people are sort of considered to be utility maximizing consumers, right? So that's one single thing. Like, you go out, somebody buys bread and somebody buys a yacht, and they both get a certain amount of utility, possibly even the same, right? That one's harder to measure, but people assume it exists. And the view of, so this is very much not what Epicure would have wanted done with his philosophy, but it's sort of what the history of the ideas turned into. The view of the economy of this perspective is that more economic growth means more income. More income means more consumption. So the more income there is on average, the more people can use that income to go out into the world, interact with the market, and buy stuff. And since they get utility from buying stuff, the more positive feelings you get from economic growth. So more is better, okay? In that perspective. If you're on Team Aristotle, you see the world in a very different way. You see well-being not as an emotional state, but as sort of more of an active sort of potential state. It's a social perspective, not an individual perspective. You measure it, if you try to measure it, you measure it through things like the Human Development Index or the Sustainable Development Goals that have multiple dimensions to them. So one of the features of well-being in the Aristotelian perspective is that it's multidimensional. It's not just one thing, it's multiple things, and you have to do every single one of them. You have to satisfy every single one of them, otherwise people are going to be materially harmed in terms of their life chances. In terms of the economy, it's a very different view of the economy, which is that the economy is there to support, the development of the economy is there to support human potential. So the goal of the economy here is not to grow just for its own sake, it's to enable humans to do good stuff and live their own lives. And this is something, if you've ever read Amartya Sen, Development is Freedom, this is very much, he's probably one of the very prominent followers of the Aristotelian line of thought today. And as you could probably tell by my very subtle explanation of this, within the Living Well Within Limits project, we're recruits of Team Aristotle. If you're on Team Epicure, we will fight you. And we wrote some nice, simple articles that sort of summarize our understanding of this stuff, and we published them in 2017 already. if anybody cares, is sort of a summary of the stuff that you might be able to use. The Brandt Correa one is more towards energy, and Lamb is more towards climate. Okay, all right, so that's fine. So now we know a bit about well-being. Okay, so what about this other part of the framework where we talk about need satisfiers? What the heck is that? Can we actually make the connection between need satisfiers and well-being? And here what we're doing is we're using the theory of human need of Doyle and Guth, a book published in 1991. And we decided to try to test it to see if need satisfiers indeed do result in well-being. Okay. And what we did is we assembled a data set. This is published in our Nature Sustainability paper that was led by Dan O'Neill in 2018. And it's an international data set where we basically looked at how needs were satisfied across the world. And what we did is we plotted something like this. So this, on the vertical axis here, we have life satisfaction, which is one of these indicators, like you go around asking people how satisfied are you with your life on a scale from 1 to 10. And then we looked at the number of need satisfiers achieved, which were things like education, sufficient food, all of these kinds of things. And if a country, all the countries that had 0 needs satisfied, we put them all in one bucket and average their life satisfaction. All the countries that had 9 needs satisfied, we put them in another bucket and we averaged their life satisfaction. And then we looked at the result and it looks like this. And we're like, oh, okay. So it's not looking so bad. So the point being that we think that we have a reasonable empirical basis for believing that need satisfiers result in well-being. We also look at physical well-being, so average healthy life expectancy versus need satisfiers. And if anything, the result is even stronger because it actually saturates. So we think we're on reasonably strong empirical ground when we're connecting need satisfiers and need theories and well-being. Okay, so this is all just sort of like baseline stuff. We think we can be reasonable when we're talking about, we know what theory of well-being we're talking about. We think we know how to measure the constituents, the things that allow us to have well-being. Okay, cool. So I am going to go fast over this part. How many of you have seen this diagram before? Oh my God, only a third. Okay, I will not go as fast as I wanted on this. Okay, so this diagram is Kate Raworth's Donut from her book Donut Economics, which is a wonderful book. I recommend that you read it if you haven't yet because it has a lot of really cool stuff in it. And basically what she says is we need to stay within planetary boundaries. So the outside of the donut represents planetary boundaries, and the inside of the donut represents social foundations. And so the point is, if you're on the outside, you're destroying your life support system. And if you're on the inside, you're failing on social goals, right? And so that's why the donut is this sweet spot, the safe and just space for humanity. And so we wanted to measure whether or not countries are actually in the donut. And so we did this, and this is the 2018 paper. So we looked at, that's France, for instance. So France is, everything that's red on the outside means that planetary boundaries are being crossed. So France has crossed, I forget if it's 6 out of 7 or 7 out of 8 of the boundaries that we can measure. But it's doing pretty well. You see very little red on the social thresholds. France is actually doing reasonably well on the social thresholds, whereas Sri Lanka, in contrast, is doing great on the planetary boundaries, no red in sight. However, there's a ton of red inside, which means it's falling short on a lot of social thresholds. Okay, so socially, it's not doing so well. And if you plot all of these things together, so you do it for like 100 countries or however many we had in our data set, and you plot the total number of social thresholds achieved versus the total amount of planetary boundaries transgressed, you basically get this plot and you just sort of plot countries on it, right? We don't care how much they cross the biophysical thresholds. As soon as they cross it, we just bump them up a notch. We don't care how much they achieve those social thresholds. As soon as they achieve it, we bump them up a notch. Okay, so you see France up there. Switzerland's not on this plot because it didn't have enough of the social data. When things were missing more than one indicator, we didn't put them on. But the data for everything is on this website, and Switzerland is there as well. Okay, and so you see France, you see Sri Lanka, and you sort of see that they live in inhabited neighborhoods of this plot, right? So there's a bunch of countries around Sri Lanka that are doing that are not transgressing a lot of biophysical boundaries, but doing reasonably terrible on social stuff. There's a bunch of countries like France that are doing reasonably terrible on planetary boundaries, but okay, on social thresholds, there are countries, check it out, they're doing terrible at both. This is possible. This is an inhabited neighborhood of this plot, right? Like, okay. The totally empty one, the really empty part of this plot, is where we need to be, which is depressing, right? It's more news from the bad news ministry. Okay, so the question then becomes, our research question then becomes, how do we go, we can't learn from existing countries because everybody is not doing great in one dimension or another or both. But we need to learn how all of these different countries can go from where they are now to that spot. And that means different things for different countries, honestly, because they're starting from very different places. And fast, hopefully, because we're destroying a bunch of stuff and people are living in very miserable conditions. Okay, so that becomes our next question. Now, the first thing to look at when you're trying to understand this problem is inequality, because the previous plot I showed you is national averages, and national averages hide huge crimes, right? The very rich, the very poor, everything in the middle. Okay, so this is a plot that just sort of shows what we're up against when we're talking about energy or climate. So it shows CO2 emissions inequality. The red are the super rich. So now we're not looking at countries anymore. We're talking about income percentiles. So the top one income percentile is, upwards of 70 tons per person. If you looked at the latest Oxfam report, you'll see that they go digging further into the 1%. It goes quite a bit higher than that. So you see a huge difference. And I'll just summarize this part. So this pie, the colorful pie shows the total global emissions in 2015. Things haven't changed that much. Not in terms of emissions, they've gone up in terms of their distribution. So we can still sort of look at this and learn from it. Okay, so the top 1% is responsible for 15% of global emissions. The top 10%, which includes the top 1%, so that's the red plus the purple, that's 48% of global emissions in terms of CO2. So top 10% richest people have global emissions. The poorest half of humanity, which is the green bit, the tiny little green bit over there, that's 7% of global emissions. So the poorest half of humanity emits less CO2, less than half of what the top 1% emits. That's a huge difference. When people ask, is climate a population problem? The answer is, which population are you talking about? It's definitely a billionaire problem. And obviously, a lot of Swiss people, a lot of the people in this room will be in that top 10% unless you're PhD students, in which case you have my sympathy. Okay, so we wanted to drill further into this inequality problem. And what we did is we did this mapping of product categories. This is a paper that came out of Nature Energy, led by Yannick Oswald in 2020. And I'm just going to show you what it shows. So basically, it's a quadrant mapping of products. And what you see is at the top part of the quadrant are things that are overconsumed by rich households, luxuries. And this is worldwide, by the way. This is not just one country, right? This is like a whole bunch of countries, poor countries, rich countries together. Okay, so this is really the international picture. And on the bottom are the things that are over proportionally consumed by poor households. So rich people consume more of everything. What's shown here is you can think of it as a share of the household budget, right? What's on this part of the plot is high energy intensity. So how much energy is mobilized in the economy when you spend $1 on that product. And these are low energy. So this will be low energy intensity on this part. And what's interesting is then we wanted to see, we just went like, just throw our data down on this, And then we wanted to see what was in the luxury and high intensity quadrant. That was one of the things we were super interested to see. And it's very simple. They are all transport categories. It's really that simple. And every transport category is in it. So the way rich people overconsume energy and overproduce emissions is through transport. This fact has since been confirmed by other people. So the larger cars, longer distances, more plane rides, more, everything. So transport is just the super unequal thing. I'll show you another example of that later. Whereas heat and electricity, that is energy used in housing. right? So you have this huge difference between transport and housing. And that means that here we have a problem that we cannot green grow our way out of. We cannot grow our way out of. You have to tax and regulate. You have to stop rich people from driving big cars all over the place, basically. Okay, and flying all the time. And in the other case, and for this high intensity but basic goods, you have to do public investment. Poor people do not want to be spending their money on that energy. They have to do it for their comfort and health. They have to do it for their basic living conditions, right? So that they don't freeze, so that they don't overheat, so that they can cook some food. So for this, you have to invest in efficiency in terms of housing and appliances, and you have to invest in low carbon provision of energy. So you have really two different kinds of policies that you can think of from this sort of inequality work. I'm going to skip this, but basically, and there's an updated version of this, but SUVs are destroying the world. Okay, like if it weren't for SUVs, our transport emissions would actually be going down from car transport. It's insane. Anyway, but this is another result from inequality. This is just showing the UK. This is data from a paper from that just came out this year. And so this is the top 10% of the UK. This is the bottom 10% of the UK. And this is their energy footprints, including international trade. And what you can see is that housing is insanely equally distributed in the UK. What is going on there? Well, what is going on is that the UK is the worst housing in the world, certainly in Europe. And so rich people can afford to insulate their houses and have efficient, so basically they might be spending the same amount of energy, but they're not getting the same energy service. That's another way to say it. Like, okay. And what you can see is that the inequality, which is massive, comes through flights and car use. Those are but also, and other transportation. But basically flights and car use is where the real inequality sort of balloons out. So we can see this internationally and we can see this nationally. And if we did it for Switzerland, it wouldn't look insanely different. And it's so bad in the UK that the richest 10% use more on flight than the poorest 20% total. So that it really sort of tells you what's going on there. Okay, so inequality plays a big role. Then we looked into things like, okay, let's look internationally and see what kind of factors enable or disable societies from achieving well-being at low energy use. And this is a study of Joachim Vogel, and that came out a couple of years ago already. And basically what we're doing is he's doing a multivariate study where you start with energy and need satisfiers, and that just gives you, a sort of bivariate relationship. But then he also wants to look at provisioning system factors. So he has provisioning systems there as well that would give you another variable. And he also looks at the relation of energy and provisioning systems through an interaction term. And that's nice because it gives you domain of validity of your result. So I recommend that method if you're thinking about doing this kind of stuff. I'm going to skip this because we don't have time to explain it. If you want, you can go back. You can ask a question. I'll just tell you the headline result, which is international. I mean, I thought we weren't going to see something much and it was going to be quite confusing. It turned out the results just like shone through, okay? Like they were super clear. We found positive factors. The positive factors, which are factors that enable societies to achieve human needs at lower level of resource use, so lower level of energy use. The positive factors are public services. If you remember only one thing from this talk, public service, high quality, available, affordable, accessible public services are the linchpin that protects people from low resource use. If you want to go to a lower resource use society, you should absolutely go and do it, but you have to provide really good public services. And that's one of the reasons, for instance, why you can look at a country like the US, which is doing really badly on a lot of things, or not as well as it should, despite having very high resource use, is because every single household has to interact with the market to get their needs satisfied. You basically have no good public services. Very similar picture in the UK as well right now, actually. Okay, income equality. So more equal societies do better. Democracy does better. That's nice. It's sort of good thing to know. And electricity and sanitation access are really important. It's not just electricity and sanitation, it's basically any kind of networked infrastructure. And that obviously is the physical counterpart to public services, right? So public services would be education, health access, that kind of thing. And you also need the physical counterpart to that, which is electricity, sanitation, transportation infrastructure, and so on. And we found a couple of negative factors that really just popped out of the data. The first one was extractivism. Extractivism is when an economy is majorly dependent for its economy, for its activities on extractive industries. So we're talking about mining, we're talking about fossil fuel extraction, so that kind of thing. So an economy that is really dominated by extractivism will do worse at satisfying its population's needs at low resource use. And that's a result that's known in economics for some long time. It's called a resource curse, it's called Baumel's disease, it's called Dutch disease. Anyway, so it's a known thing, but we were able to see it in the data. The other thing is economic growth above a moderate income. So growth-oriented economies have a hard time satisfying their population's need, or a harder time satisfying their population's needs at low resource use. Okay, so that gives us already sort of an idea of where we should move towards, like what are the factors we should push harder on with a plus sign, and which factors we should move away from if we want to shift our societies to allowing to achieve human needs at low resource use. We can also model something, right? So we tried to do some modeling of how we could model a high well-being and low energy future, and what would it look like. We're doing this based on the decent living energy framework that was developed by Professor Narasimha Rao at Yale University. I really encourage you to go look at this stuff, it's great. And the model basically connects human needs to sufficient levels of energy services. It's a global model, so we do it for every single country based on their conditions. It takes into account technology improvements. So the technologies are efficient, but they're not crazy. Okay, it's not like the IPCC models where they have like God knows how much negative emissions. It's not like that. So the technologies are possible, at least certainly by 2050. Equal distribution, so it's obviously very utopian or dystopian depending on your politics, and lower demand levels. Results in lower demand levels. This is what the model looks like. You basically have your decent living standards here, translating into personal consumption. You'll see there's lots of like clothes, washing and drying, hot water, thermal comfort, phones, computers, whatever. There's public consumption in hospitals and schools. There's private consumption and infrastructure. So we can throw it all in. And that's the services per person. We can go back into that. I'm going to try to speed up a little bit. And what we find, I'm just going to summarize it, is that decent living energy for all would be achievable at 40% of current energy use despite population growth until 2050. So it is entirely possible to satisfy everybody's needs at low energy use, given plausible technology levels. It's possible. It doesn't mean we're going to go there. It's just that it's technically possible. That should be something that's feasible. What would it take? So this is not our work. This is work by Jarmo Kikstra of YASA that came out in 2021. And I should have said the previous paper was by Joel Millward Hopkins, or led by him. And what Jarmo Kikstra and colleagues did, including Narasimha Rao, is they looked at how much you would have to invest in infrastructure in order to get to decent living standards at low energy. And what's really interesting is, it's a huge amount. 290 exajoules corresponds to about roughly half of current energy use levels, so globally. So this is a lot of energy to invest. However, you do it over several years, so it starts being reasonable. And most of it is in shelter. They have it both by sector and by geographic area. And you can see that most of it's in shelter. Look what happens to shelter after the investment. It becomes all tiny. That's because it is technically possible to make housing that doesn't use a lot of energy, right? So you need to invest in it, but then it works. You have to invest a lot in mobility. Mobility, physics is real. Even in a low energy future, you're still going to use energy for mobility. It's going to be the lion's share. All right. So things are possible, but it would take a lot of investment. So we basically have learned that it's possible, technically possible, to satisfy people's needs at low energy use. If we're thinking about what's standing in our way, we start thinking about political systems and economic systems. And what we did is we looked at the political economy of car dependency. So now we're really looking more just into the provisioning systems themselves. And we also looked at electricity, and yeah, so we did some of this political economy work. So I'm just going to summarize it for you. Provisioning systems could enable good lives at low resource use, but are often engineered to create resource dependency. So that's one of the things you have to understand about the political economy, is that it's working against us right now. There's a huge amount of possibility out there. Right now, the systems are very much working against us. So dependency on resource-intensive consumption is itself an industrial product. And this is something to understand from the history of economics. If you think about economic systems, and I'm going to call it capitalism because that's sort of what surrounds us, capitalism was able to make profits from selling people stuff they wanted, up until a certain point in time when people had all the crap they wanted. And then they stopped buying stuff, and then that was going to be a crisis. And then capitalism invested massively in things like advertising, premature obsolescence, planned obsolescence, and just sort of things to keep. Basically, if you have an overproductive economic system, you need an over-consuming population. Otherwise, you have a crisis. So to avoid a crisis, capitalism engineered overconsumption. And this is something we can study. We study it in sort of historical studies. And it's helped by so basically, in doing so, industries made the state, our governments, accomplices. And we can study this stuff. I don't have time to go into it. If you're interested in how it worked for the case of car dependence, look at this paper that was led by Giulio Mattioli, which is quite, I think it's really a stunning piece of work in terms of studying the evolution of car dependency. So Giulio's point was, the main product of the last century is not the car, it's the creation of car dependence. And car dependence is driven by the car industry, roads and parking infrastructure, land use planning for car, active neglect of public transport, and the creation of car culture. And all of these things together bring us towards car dependency. Okay, I'm going to skip this. That was, maybe I'll just end with this. Because we basically contributed, at the time we were in the UK, I was in the UK as well, and Philip Alston, who was the UN Special Rapporteur on Extreme Poverty and Human Rights, visited the UK in 2019 when my team was there. And he said, he knew one of my colleagues, and he said, I'd like you to tell us about privatization. And and what that means for poverty in the UK. And so we contributed to his study, we brought him the evidence, it turned into one of our papers. And his conclusion from our work was, this is really based on our research, abandoning people to the private market in relation to services that affect every dimension of their basic well-being without guaranteeing their access to minimum standards is incompatible with human rights requirements. And so I think that's a pretty strong statement. So this research, so the Lily project has now ended. I was fortunate enough to be able to work with Yorgos Kallis and Jason Hickel. We acquired a major European ERC grant, an ERC Synergy grant, which is on post-growth economics, or degrowth. And I'm going to be looking at, we're going to do a whole bunch of stuff. I'm specifically leading the part on post-growth provisioning. So understanding basically how we democratize the economy and change this political economy landscape in order to be able to achieve lower resource use. So basically how we find pathways to change things. We're going to be doing a whole bunch of modeling and cool stuff. And I always end with this slide. I think it's honestly, yeah, it's not enough to just do research. We also have to stand by the knowledge that we generate. And I think that means getting into the street and possibly getting arrested from time to time, even though that might be not so comforting. And we've actually started writing papers, like me, but also other people have really started sort of explaining to other scientists what this means. So yeah, you can have a look at some of these papers, which help explain what that might look like. Thank you so much.